So here we are, and we are reading a book. Yeah, I figure I should just do an introduction on every video of on what I am doing. So the previous videos do not have it, but this is a very raw series where I do not edit the videos. I just cut them at will while I register, and it is a registration of me reading this book, which is Real Word Haskell. This is the book, Real Word Haskell, and I am just reading chapter 10 now, and I am implementing it. I already read it, I am implementing it, and to learn it better, I explain the stuff I do. And if you do not understand something and you might want another opinion, uh, you are the perfect audience for this. Just, maybe try to read it and then listen to me rambling if that works for you. So last time we basically got to we implemented this parser, and we implemented it, but it did not work. So it did compile. If I write main, it gives an error because there is a call to undefined. That means that one of these parser helpers was called, and undefined is a placeholder in Haskell. If you call undefined, you basically, it compiles, but once it gets there, it doesn't work. You also have things like this in Rust, which is, I also did this in Rust. I might do a tutorial on it. I don't know. So, parse. Oh yeah, if you're interested, I also implement the things in the book, Real Word Haskell, in Rust. There are like interesting things like trying to emulate monads in Rust and all of those things. Okay, so parse header. We need to parse the header. So what is the header? The header is basically the p5 on the thing. I should just like have a window open here with the input. So we are parsing a PGM file, and the PGM file is structured like so. It has an header and it has things. Okay, so we need to parse this p5 part. Let's do this. So we need to basically match a string, and to do so, let's see. L8. Sorry, I had to interrupt a little there. So yeah, parser. So we need to parse something that is the p5. So we need to parse that p5, which I explained before. To do it, we will first check if it is a prefix. So prefix of or something like that. We will check later if the function is called that way. So you can call functions as if they were binary operators, infix binary operators, by just using these weird quotes in Haskell. No idea what they're called. I think back quotes. Just use those. So input. Yeah, so let's check if p5 is the prefix of, no idea what that was. So let's check if p5 is a prefix of the input. In case it is, and we could use an if, Yeah, let's just use an if. Okay, so if the p5 is the prefix of the input, then then we will return it by parsing it. So let's just do like just, and we will consume the p5, because this means that the p5 we are interested in just matched. So we will return a match by just returning nothing, and what is left of the string, which would mean that we need to like drop or skip. No idea. We will check it later. I think it's skip. So how much we will skip? Basically the length of p5, like the length of p5 from the input string, and we will return that. So yeah, just skip how much, like the length, and then just return it as the rest of the string, because I repeat this here represents the rest of the string. And yeah, I guess that's that. And in case we do not match, then we do not match. Yeah, of course this doesn't work. P5, I think I'm going to call it like header, and let's put it as a parameter so that I can just do this. And length doesn't work because header will be a byte string. So let's just do this. Yeah, and yeah, that's that. So we skip what we need to skip, and that's it. So let's see if these are actual functions. Oh, this is how he did it, so we will look at that later. So I open the Google here, and he doesn't understand, but Google is just like a Haskell Google. So you can search for functions. So let's see if I on L8. Alright, so as I was saying, interruptions are very not where I am now. So we can search for functions on Google, and well, you can search for functions that are you think are on Google, and but the problem is we need to put the full name of the module, so you know, data that byte string. Let's see, data that byte string, that it's like byte string, and let's just search for prefix of and see. So there it is prefix of. And you know, occasionally I will like install auto completion so that I can do this, you know, within Vim. But you can use a browser if you're like a minimalist type of guy, you know. So yeah, it's prefix of. So there actually is a function is prefix of. So let's see if like there's a skip function, which is also, I don't know why I erased it. So byte string skip. Yeah, no skip. So let's see drop. Yeah, yes, it's drop. So you see, just like intuition. Because there's always a drop function, you know, in every stream-like thing. By stream, I mean like functional stream of values, like you might call it list. There's always a drop function. It takes as a first argument, it takes the number of things to drop, which is of course the length of the header, and as a second argument, it takes the input. So this is basically a parser generator now, because it, you know, it takes an L byte string and it returns a parser, which is this thing. So you know, we are doing this is the parser. This type represents the parser, and you can see this is a function that takes a string and outputs, you know, output a parser. And this is because you can put parentheses around every, you know, little pattern in Haskell. This has a name. I call it associativity of this arrow, because it basically is. And you can think of this way. You can think of it in you know, with another grouping of parentheses. But that's just theoretical stuff. You can generate the parser with this. If we call this, we will generate something that will be a parser. As we go on, you might understand that statement a little bit more. Okay, so this should work. Formatting works, which is already a good sign. Let's go in here, word Haskell. So stack GHCI. Wait for GHCI to work. I was actually trying to install something like that would have gave me auto completion, but there is an error, so I guess I will do that later. Okay, no idea why this is happening. I'll get back to you when this is done. Okay, it works again. So yeah, I basically erased my entire stack folder. That's why it didn't work, but that's not important. So let's run this again. No idea why I exited, and let's see. There is an error. So you're gonna want to see the first error, not the second. Well, it's only one error. So could that match expected type? Well, wasn't it once? Yeah. Okay. Yeah, I know what this means. So he wants like a string that I'm trying to explain everything. This is why I'm doing these. So as you can see, when Haskell tells you this, it wants a function actually. So this is the type of function, you know, first argument, return value, and it wants this type. Well, not this type. He wants. Yeah, yeah. Let's go see. I couldn't remember which is which. So let's go to line 31 as it is specified in the error message, and. So right here, you know, in the pattern just rest. So right here, I am trying to destructure the output of this function, and the output of this function is a function. This because of carrying rules, yeah. Because I called this only with the first argument, so I basically just called it with the other, and so Haskell figured I wanted to return a function which has as the other the input value, you know, because first argument is other, and so instead of header here, the Haskell basically thought that this input value was supposed to be header because it is the first argument of this, and then the second argument was not specified, so Haskell returned a function which has a fixed header. So basically as if I had like a function like this with the header that is fixed and has the value of input. This function here, hypothetical function here, which only takes the input and has a fixed header, is what is returned by this. So then the value is destructured here, but it is destructured in a wrong way because I'm trying to destructure a function with a maybe value. This is what it's telling me, you know. It's a function value and I am trying to destructure it as a maybe value. So I can't do that because a function is not a maybe value. So this is like a contorted way to just anyway, I wrote that so to say that we need to call it with other arguments. So it's really first time you see it, it doesn't seem like it is telling you that you missed an argument. But maybe it says you like you might be missing an argument. No, it doesn't. Well, it should, but this actually means that you're missing an argument. So, and I hope you understood why it means that you're missing arguments. It's a very contorted and theoretical way to explain that you're missing an argument. Okay, so now I should reload. Yay, shorter error. So, yeah, header doesn't exist. So let's, you know, do this. This is the actual header we need, and it works. Right, main, there's an undefined. So what does main do? It tries to parse that thing, and it calls undefined. It is called, as you can see here, at line 22, which is here. We need to implement this. But what if I want to just, you know, get the output of this? Well, I can't because I need this. So let's actually make this. But first, let's test that. You know, it's a good practice to test things. I am not going to use test-driven development, but I am going to do as if I had, you know. I'm going to make a little test section. Well, not even that. Yeah, I'm not going to use test-driven development yet. So I'm just going to test it in a main, which is right here. So I'm going to copy this, and I'm going to do the same thing. Well, that's not what I wanted. And the same thing. Well, I'm going to test the function we just wrote. So, what was it? Parse there. to pass it the, just a test function, test header, and I'm going to so it should parse. And well, let's actually just, that's fine. Let's need show, because I need to transform this, which is going to be a maybe value, into a string, and then the string is fed to put string, which is going to just print a string. Okay. Yeah, it worked. Let's do it twice, which I have no idea how to do it twice in Haskell in an elegant way, so I'm just going to be ignorant about it. Just repeat this twice. Yeah, but we just can't do this in sequence. Yeah, it's very hard to do things in sequence in Haskell. So I guess I won't do this yet. I will believe that this works. Okay, so it works because it parsed the test string. It just gave back test, and it parsed nothing, because that we don't need info. We already know that if the header is there, we don't need to extract any info from it, so we just return the empty type. So now let's parse a natural. So I have a sentiment that there's going to be a parse natural function. I think it is called readInt. What I'm going to do is I did before, and just search for readInt, and so it returns a maybe int byte string. So as you can see, it basically is a parser, and we can just steal it. Yeah, it's the same type, so we just steal readInt for our parse natural, and hope that it returns the same type, or it does. So then let's do this one, parse bytes. So parse bytes, what do we want to do with parse bytes? We want to parse the byte section of our files. So as I said, we are probably going to use the L library, which only treats the byte string as a normal byte string, only has byte manipulation functions, and one of those must be like get bytes or something. Might be like consume, I don't know, but we're just going to assume that there is a function that lets us take any amount of bytes from the input string, and but I don't really know if there is one. So here I'm going to actually see if the book has anything to say about this. So yeah, I actually did something different here. Oh, because we're going to do this. So without watching we're parsing a natural number, which means that it cannot be greater than, or it cannot be less than 0. So here we are going to do as he does, and we are going to accept an input, which we are going to say here, and then we are going to do, well, in case nothing happens, we are just going to do nothing, and in case something happens, like we have an int value, we're going to check if it is less than 0. Well, in this case then we are going to just return nothing, else we're going to return I, but we're going to wrap it in just, and we are going to also take the rest from here. I'm going to copy this, so there shouldn't be, well, no, yes, there should be. Okay, so then nothing. Yeah, if it is less than 0, then we cannot parse it, because it's a natural number. If it is 0 or it is more, we can then return. So that's it, and let's format this. Should work. And also, let's see how he did it. Well, he just used guards like this, which is very guards. So let's do it with guards. No idea why 0 is not allowed, because it does not allow 0, but we're just going to trust him, of course. But I do not know why 0 is not allowed. That might just be a typo. So he did it with if, he did it with guards, which is just using these things. They are called guards. And they work at the expression level, so this expression here is going to return nothing if this is true. Otherwise, it's going to go into the otherwise branch and just return this. Yeah, also, I don't know if he does, he doesn't. Oh, he also uses from integral. Interesting. Shouldn't really need to do it because, you know, as it is specified here, we just need if it returns an int, we would need to call it integer. Well, that might be a typo. So it returns an int, so I don't know why this is required, but yeah, I'm going to. Yeah, it should work. Okay, that's weird. We could have used like this thing, and I'm going to actually go see how it works, and I'm going to get back. So yeah, I changed stuff, but only like this. So as I was saying, we could use the, just wrap this in parentheses. Okay, we could use the add operator, which lets us basically it lets us store things in variables as we are pattern matching. So this match, if this is matched, the result is stored in appropriately enough result, and so we could just return result. So first here it was like a duplication, now it's just result. So just a little thingy you can do, and yeah, I guess this is it. And so what now? Yeah, I'm just going to go with my intuition and say that we're going to allow 0, because it should be allowed, I think. Oh yeah, of course it's not allowed. Yeah, because it's a width value. So yeah, the name is misleading, but we are going to use this to parse width and height values. So 0, of course, is not allowed. Okay. So in a real program, I might have like changed the name, but I don't really care here. So parse bytes. We are parsing, parse bytes. Alright, so we need to know, we need to like see what the function is called that parses the bytes. So I'm going to see like, it's also called parse bytes. I'm going to see, here's the implementation. So, this is like way in the future. Or you only like declares it later as a complementary function. So let's like just search manually. It's just called get bytes. Okay, so I'm searching get bytes with the browser search function. Let's see. Here's the implementation. He does a lot of weird stuff. Okay, I'm going to understand this directly because I do not remember any of the like details of this. So we're going to get the bytes, let count from integral. He likes to use this from integral function, which I'm guessing is just like a conversion from integer types, but we're not going to need this. So he uses split at count and on an str. Okay, and it just stores things like in a prefix, which we're going to need. The tail is really not needed. And then if the length is less than count, nothing otherwise. Okay, so this tells us a lot of things. First of all, we're going to use the split at function. And I got, I understood this enough to copy it. So first of all, we are going to need a split at function, which is going to split the byte string at the amount point. Okay, so if I have like hello there and I pass it an amount of 5, is going to split it after hello, because hello has 5 letters, does it? HALLO, Yes, it does. Okay, so it's going to split there. So we want to do exactly that. We want to save that. Well, this is going to, return a tuple. The let value just lets us store things in variables, and of course, because this is Haskell, we can pattern match. And we can pattern match against the tuple, which is going to be the result of this. And mind you, we could not pattern match, we could just say result, and this would be a tuple. But let's destructure the tuple and let's get the head, which is what we need. We don't need the tail, so we could write tail, but if we don't need it, we don't need to call it. So we are going to call this result, which is going to be the result we need. But this function might return. It might not return enough things because the enough characters, enough bytes, because the input is too small, and so because of this we need to check it. So let's check it. Okay, let's check if it returns enough things. So if, and in let statements we can just this, I think. Let me see if that is the case. Yeah, we need the in keyword, and then we can do things. Okay, so after this in keyword, the bindings that we declared in the let statement will express, it's really a let expression, will work. Okay, so we can refer to result here, and yeah, let's see. We have to put the return value here. So just split that amount. We have the result. Let's return the result. But what if the result is too short? So let's see if the result is too short. Not length. Need to, of course, get the length of this. I'm just using L because I need to see how many bytes are there. So L treats the thing as bytes. L8 treats it as valid UTF-8. So we don't need to interpret this as UTF-8, just as bytes. So how many bytes are in result? If that is less than the amount of bytes that we want, well, then something is wrong. So we're going to return nothing else. We're going to return result. Result, what is result though? Well, it's a byte string, so we need to turn it into a list of integers, and this is something that the book doesn't do. So I'm still going to try this, but I'm still going to try this. Okay, so let's see. I'm hoping that a map function is in the L things. It's just going to map things over each byte. And let's map a function. So yeah, these are like the functional functions that you always have in this kind of frameworks. Let's see. I'm going to pass in a function that takes a character and turns it into an integer. So how will it turn it into an integer, you say? Well, what's a byte? What is the type of a byte? I do not know. So let's go on Google and find out. So amp. Yeah, a word 8. So I'm hoping the function is the first argument. Yeah, as I'm giving it, you see, first argument is a function from word to word, and then there's a byte string, and then there's a byte string. Okay, so y2. Oh yes, the second byte string is the result. Okay, so which is awkward because we want to return something from another result. Yeah, I'm just going to skip this step. I will do this thing with map at a later point. So we just build returning list of ins, just going to return a byte string. Okay, so now this should work. just formatted it. So this of course means that this is going to also be a byte string, and wherever I just wrote this is not matching properly because like parentheses, I need to escape things. So no more of that. Okay. So yeah, I just refactored a bit. Okay, but this needs to be wrapped inside the just, and it's going to be a tuple, which, well, we actually need the tail, but I think he uses the at operator because we can actually, we can exploit the at operator. Let's just like call this result, and let's call this something else like head. Okay. Yeah, so we exploited the at operator because this tuple is exactly what we need. It is the return value we need because the underscore represents the tail, which is the rest of the string, which is exactly what we are not parsing. So yeah, this function is done, and it doesn't work. Yeah, because I got the operator wrong. Now it should, it formats. Let's reload this. So amount is not specified, or maybe, no, that's not the problem. Let's see. Oh, it wants an int 64, but it has an int. So I am going to just use the from integral thing. Boy. Okay, so it still doesn't work. Oh yeah, it's in the first argument to split at. So to do this, I will clean this later, and it does work. So I'm just going to do this in another like let branch, or however you want to call it, let item, I don't know. So I'm also going to try like giving it the same name as something you often see, so it's not complaining. Yeah, it works. Okay, so I basically just transformed the binding amount to a version of amount, the old amount that is of the type that split at once. And why is it exactly the type that it wants? I guess it's from magical things that from integral does, working with type deduction, which is really a big part of Haskell. Okay, so, and mind you, this technique it does not substitute the value of amount. It creates a new binding, a new variable, new alias, which is called amount, which overshadows the old amount. So the old amount still exists, but it is overshadowed by a new thing called also amount, which happens to be equal to an other integral version of amount. Okay, so we have parse bytes. It seems to work. Let's see if main works. It does, because it should return nothing. Okay. Well, yeah, it should. Yeah, that's fair. Because it like parsed the P5 and then it parsed the. So let's see. But it should not go here. So let's see if I write undefined here. Now it should not crash because it should succeed in parsing the P5. And then in sequence, it should try to parse the natural arithmetic. So just reload it. Indeed, it does not arrive at this branch. Undefined crashes the undefined crashes the program only if you actually run it. And let's see if I type it here, it should now crash, and it does. Line 45, and this is exactly the line. Yeah, vim, just type colon 45, go to line 45, and it's exactly the undefined. Okay, I guess we just implemented So we actually the default implementation. We are at 32 minutes, which is already a lot. So next time we are going to implement. Yeah, we're going to make this work, and then we also need to clean it and implement all the other thingies, and actually use monads to make it work in a more elegant way. So, see you later.